So any more questions you have before I start, Raj? For your question? So we'll start with the load line, keyboard assignment. अब एग्जाम्पशन जो आपके लोड लाइन कन्वेंशन के हैं, वो बेसिकली इट्स नॉट फॉर द warships. It is not for new ships of less than 24 meters length. It is not for existing ships of less than 150 gross tonnage. Pleasure yachts, not engaged in train and fishing vessels. Plus, exemptions can also be granted, like for your hatchless container vessels where you don't have hatch covers. So those are special exemptions. Now, the principal conditions which has been to be satisfied before your freeboard is to be assigned is first is your structural strength should be there properly as per the class. Your reserve buoyancy should be preserved. You should have physical means of preventing entry of water into the hull. This should be safety to the crew on the weather deck. There should be the potential wetness on weather deck should be reduced. The stability in normal loaded conditions should be mentioned in intact stability requirements. Then your degree of subdivision and stability after damage or damage stability should be prescribed. What is your damage stability requirements for that? And you should be confirming with that. And your seasonal zones, areas, and periods to be determined for appropriate load line. And accordingly, your tropical, summer, and winter freeboards to be given as per the weather criteria. So your summer zones will be regions where not more than 10% of wind speed is exceeding force 8. Tropical zones are areas where your regions measure not more than 1% wind speed exceed force 8 and not more than one tropical TRS in 10-year period occurs in the area of 5 degrees lat long square in any one separate calendar month. And winter zone is all other areas. So your master or a ship owner cannot submerge your relevant load line in your still conditions. Otherwise, it'll be your class is going to invalidate your certificate, and that will lead to criminal prosecution. You should not submerge the load line, relevant load line, below your still load line water. Still load line. Now we come to the definitions. Definitions कई बार आपके एग्जाम में आते हैं. तो फ्री बोर्ड कैलकुलेशन के डेफिनेशंस क्या क्या हैं? पहला तो लेंथ पे आते हैं. तो लेंथ बेसिकली एलबीपी है, लेंथ बिटवीन परपेंडिकुलर्स. तो फर्स्ट द फॉरवर्ड परपेंडिकुलर ये आपका आ गया, जहां आपका परपेंडिकुलर इज कटिंग द four side of the stem at the relevant water line, that is your forward perpendicular. Aft perpendicular, wherever it is passing through the center line of your rudder stalk or aft portion of rudder stalk, that depends on your class किधर वो ले रहा है aft perpendicular. इन दोनों के बीच में आपका LBP आ जाता है. So it is taken as 96% of the total length on a water line, 85% of the least modal depth. So molded depth is at your midships. Is molded means it's above your the plate, internal plate. That is more your molded. That is not outside the plate, but inside the plate से ऊपर तक जो depth है till your uppermost continuous deck, ये आपका depth हो जाता है molded. उसका 85%. मतलब 96% total and on water line at 85% molded depth. तो जो water line है 85% molded depth पे or as a length of the foreside of stem to the axis of rudder stalk, whichever is greater. तो या तो वो 96% of total length होगा at 85% of least molded depth होगा, और forward perpendicular आर्क परपेंडिकुलर के बीच में होगा, जो भी इससे ज्यादा, दैट इज योर लेंथ। देन योर forward and arc perpendicular क्या है? Forward perpendicular is a perpendicular which is at the foreside of the stem on the waterline. जो perpendicular आगे है waterline पे कट कर रहा है, summer waterline SWL पे, on which your length L is measured. Arc perpendicular जो है वो axis of rudder stalk पे है on that waterline. Amidships आ जाता है इन दोनों के बीच पे, और midships of L is amidships. Forward and arc perpendicular के बीच में that is amidships. तो जब आता है ये डायग्राम साथ में बना देना. Normally you don't make the diagram, but इसके साथ डायग्राम बनाओगे तो better you will have more full marks. Either of this you make the diagrams. LBP or your breadth is your maximum breadth of the ship measured amidships to the molded line of the frame in the ship with a metal shell, and to the outer surface of the hull with the shell of any other material. अगर metal hull है, then it is the molded line of the frame, मतलब inside, और to the outer surface of the hull अगर कोई और material हो तो outer surface of the hull होगा breadth maximum at midships. About what is molded depth? So molded depth is the vertical distance from the top of the keel. Top of the keel मतलब कील के ऊपर, क्योंकि कील की थिकनेस है, certain thicknesses है, तो top of the keel to the top of the freeboard deck beam at this side. कील के ऊपर से freeboard deck के ऊपर तक, not thickness को मिला के, that is taking the thickness of the freeboard deck. So top of the freeboard deck beam at the side. Now when you have a rounded gunwale का मतलब है, इधर ही दिखा देंगे राउंडेड गनवेल क्या है. ये वाला आपका राउंडेड गनवेल, ये वाला, दिस इज राउंडेड गनवेल, ये स्ट्रेट गनवेल, राउंडेड गनवेल. So ships having rounded gunwale, the molded depth shall be measured to a point at the intersection of the molded line of the deck and the shell plating. Line extending as though the gunwale was an angular design. मतलब कि ये इंटरसेक्शन पे, अगर ये सीधा रहता है और ये सीधा रहता है उसके इंटरसेक्शन पे, ये वाला, ये पॉइंट, ये वाला, इधर ये पॉइंट, ये अगर सीधा है और ये सीधा उसके इंटरसेक्शन पे ये लगा है. Where the freeboard deck is stepped and raised part of deck extending on the point at which the molded depth is to determine the molded depth shall be measured to a line, a reference extending from lower part of deck along a line parallel to the raised part. तो फिर ऊपर वाले पार्ट पे उसको मेजर किया जाए. That is line reference extending from lower part of the deck to a line parallel to the raised part. वहां उसको रेज किया जाए. अब आता है व्हाट इज डेप्थ फॉर फ्रीबोर्ड. So depth for freeboard is a molded depth amidships plus molded depth amidships को add किया जाएगा plus the thickness of freeboard deck stringer plate. I'll just tell you what is a freeboard deck stringer plate. Suppose ये राउंडेड है तो स्ट्रिंजर प्लेट इसकी हो जाएगी ये वाले, इसके ऊपर एक स्ट्रिंजर प्लेट आती है, फिर आपकी डेक प्लेटिंग यहाँ से शुरू हो जाती है. तो ये वाली स्ट्रिंजर प्लेट आ गई. अगर सपोज ये वाला है स्ट्रेट वाला, तो स्ट्रेट वाले में आपका गनवेल सीधा आएगा ऐसे, और इसके जो स्ट्रिंजर प्लेट आएगी यहाँ वो ये वाली आएगी. ये स्ट्रिंजर प्लेट आ गई, इसको मैंने अगर ऑरेंज कर दिया, ये स्ट्रेस पार्ट में ये स्ट्रिंजर प्लेट आ गई, नहीं तो ये वाले पार्ट में स्ट्रिंजर प्लेट आ गई। उसके बाद मेन प्लेटिंग, डेक प्लेटिंग आ जाती है। सो वी आर टॉकिंग ऑफ द स्ट्रिंजर प्लेट। सो दिस मोल्डेड डेप्थ अमिडशिप्स जो हमने लिया है, मोल्डेड डेप्थ प्लस द थिकनेस ऑफ डेक स्ट्रिंजर प्लेट वेयर फिटेड, प्लस उसके साथ में अगर उसके ऊपर शीदिंग दी गई है, मतलब उसके ऊपर लकड़ी लगी है फ्रीबोर्ड डेक पे, तो इन दोनों के साथ T इंटू एल माइनस एस बाई एल आता है अगर वो शीदिंग दी गई। अगर नहीं दी गई तो आपका डेप्थ आएगा प्लस थिकनेस ऑफ फ्रीबोर्ड डेक स्ट्रिंजर प्लेट आएगा। बट अगर शीदिंग दी गई तो उसको भी ऐड किया जाएगा, जहां T है मीन थिकनेस ऑफ एक्सपोज शीटिंग क्लियर ऑफ डेक ओपनिंग्स, S is the length of superstructure, इतना लेंथ आपका सुपरस्ट्रक्चर। तो नॉर्मल केस में आएगा डेप्थ, मोल्डेड डेप्थ मिडशिप्स प्लस थिकनेस ऑफ फ्रीबोर्ड डेक। अगर उसमें एक्सपोज शीट हुआ तो मोल्डेड डेप्थ मिडशिप्स प्लस थिकनेस ऑफ फ्रीबोर्ड डेक स्ट्रिंजर प्लेट प्लस T into L minus S by L. Now the depth for freeboard having rounded gunwale with a radius greater than 4% of the breadth और हैविंग टॉप साइड्स ऑफ अनयूजुअल फॉर्म। टॉप साइड्स का मतलब है जहां बल कैरियर आ गया तो वो राउंडेड है, प्लस उसका टॉप साइड टैंक इज ऑफ अनयूजुअल फॉर्म विद द डेप्थ ऑफ फ्रीबोर्ड हैविंग अ मिडशिप section of vertical top sides and with the same round of beam and actual top side section equal to provided by actual midship section। तो उसके ऊपर ये डिफरेंस आ जाएगा अगर उसमें टॉप साइड टैंक है। तो उसमें वो चेंज आ जाएगा, अदरवाइज वाला ये वाला होगा, क्योंकि अगर वो राउंडेड है तो। अब आता है व्हाट इज ब्लॉक कोफिशिएंट। तो ब्लॉक कोफिशिएंट का मतलब है बेसिकली व्हाट, पहले तो आपको लेमैन वर्ड में ब्लॉक कोफिशिएंट समझा दे। सपोज ये मेरा एक ब्लॉक है लकड़ी का, अब इस लकड़ी से मैंने कितना लकड़ी यूटिलाइज किया शिप बनाने में। अगर मैंने एंटायर लकड़ी, बहुत ज्यादा लकड़ी यूज कर दी तो मेरा ब्लॉक कोफिशिएंट ज्यादा होगा, अगर मैंने लकड़ी कम यूज करी तो मेरा ब्लॉक कोफिशिएंट कम है। जैसे सपोज एक नॉर्मल हमने एक बोर्ड बनाई है इस ब्लॉक ऑफ वुड से, अब मैंने 50% 40% ही लकड़ी यूज की इस बोर्ड को बनाने के लिए, तो मेरा ब्लॉक कोफिशिएंट हो जाएगा 0.4। लेकिन सपोज मैंने एक VLCC बनाया जिसमें ज्यादा से ज्यादा लकड़ी यूज हुई, तो ब्लॉक कोफिशिएंट हो गया मेरा 0.85। 85% मैंने लकड़ी यूज कर ली बनाने में। तो ब्लॉक कोफिशिएंट का मतलब है मैंने एक लकड़ी के ब्लॉक से कितनी ज्यादा मटेरियल यूज किया वो शिप बनाने के लिए। पहले मैंने सोचा आपको लेमन वर्ड में समझाऊं, उसके बाद मैं फिर फॉर्मूला पे आऊं। So block coefficient CB is volume of the displacement at the draft 0.85 of depth. 0.85 of depth मतलब 85% of depth for freeboard divided by LBP, length into breadth into draft, which is at 85% of least molded depth. Draft होगा least 85% of least molded depth. तो वॉल्यूम ऑफ डिस्प्लेसमेंट एट ड्राफ्ट 0.85। कई लोग आप लोग लिख देते हैं वॉल्यूम ऑफ डेड वेट लिख देते हो, तो वो रॉन्ग हो जाता है, जीरो हो जाता है। सो रिमेंबर इट इज वॉल्यूम ऑफ नॉट डेड वेट बट डिस्प्लेसमेंट, उसके आगे लिखना पड़ेगा ड्राफ्ट 0.85। अगर ये भी मिस कर दिया तो मार्क्स कटेंगे। यू हैव टू बी वेरी पर्टिकुलर, क्योंकि जो मैं पेपर चेक करता हूँ कई चीजें मिस आउट हो जाती हैं, कई बार वॉल्यूम ऑफ डेड वेट लिख देते हो तो पूरा 0 है, वॉल्यूम डिस्प्लेसमेंट लिख जाते हो, ड्राफ्ट नहीं लिखते तो उसका 50% कट गया। तो ये लिखना पड़ेगा ड्राफ्ट 0.85 डी divided by L into breadth into draft at 85% of least molded depth, और CB को less than 0.68 नहीं लिया जाएगा as per load line rules. You should not take CB less than 0.85. Standardized है 0.85, नहीं तो फिर करेक्शन लगेगा और ब्लॉक कोएफिशिएंट, क्योंकि जनरल कार्गो के वेसल्स जो हैं उनका ब्लॉक कोएफिशिएंट कम होता है, मे बी 0.6 होता है, तो उसके लिए वो आपका करेक्शन फॉर ब्लॉक कोएफिशिएंट अलग से लगेगा। अब आता है फ्री बोर्ड। तो freeboard design is the distance measured vertically upwards or downwards emissions from the upper deck edge of the deck line to the upper edge of the related load line. We're taking from upper to upper. अब आता what is freeboard deck? Now this is normally the uppermost continuous deck. अब कई बार आपका freeboard deck is a bulkhead deck because कहाँ तक आपके bulkheads आ रहे हैं उनको अगर join किया जाए, so that is bulkhead deck because सारे bulkheads को कहाँ join कर रहा है, that is freeboard deck. It can be bulkhead deck also, but freeboard deck हर एक जहाज में अलग अलग भी हो जाता है, कई बार discontinuous freeboard भी हो सकता है, कई बार रो वेसल में अलग से freeboard deck होगा क्योंकि उसमें अलग अलग डेक्स हैं। नॉर्मल शिप पे तो एक ही डेक है, बट रो वेसल्स में अलग अलग डेक्स हैं। अब उन कंडीशंस में क्या बताते हैं? So normally the uppermost continuous deck exposed to the weather and sea, which has permanent means of closing all openings in the weather deck thereof, and below which all openings are fitted with permanent means of watertight closing. इसका मतलब इसके ऊपर जो भी होगा वेदर टाइट होगा, इसके exactly on whether freeboard deck and below will be watertight. जैसे आपके मैन होल्स अगर इसके ऊपर हैं फ्रीबोर्ड डेक पे, तो दीज विल बी वाटर टाइट. वाटर बिलो दिस डेक will be watertight. So in a ship having discontinuous freeboard, suppose आपकी freeboard यहाँ है, उसके बाद discontinuous होगी greater than 1 meter, the lowest line of exposed deck and the continuation of line parallel to the upper part of the deck is taken as freeboard. तो जहाँ discontinuous है उसके लोएस्ट लाइन को हम लेंगे. सपोज आपका ये आपका फ्रीबोर्ड डेक बनाया हुआ और यहाँ डिसकंटिन्यूस हो गया मोर देन 1 मीटर, तो फिर इसके लाइन जो पैरेलल है उसको हम फ्रीबोर्ड डेक लेंगे. एंड दैट शुड बी एट द एटलीस्ट द मोल्डेड डेप्थ. मोल्डेड डेप्थ होना चाहिए. Now, owner may opt to designate a lower deck as a freeboard deck, provided that it is a complete and permanent deck in a fore and aft direction between the machinery space and the forward and aft bulkheads. Peak bulkhead means fore peak and aft peak bulkheads, and continuous athwart ships. इधर से इधर वो continuous हैं और athwart ships में continuous हैं. This is on ro-ro vessel. In such cases, the part of hull that extends above the freeboard deck may be treated as superstructure for calculations of freeboard. तो इसके ऊपर जो स्पेस होगा, अगर हमने वो वाला फ्रीबोर्ड डेक लिया जो यहाँ से यहाँ कंटिन्यूस है मोल्डेड डेप्थ पे, तो लोअर एनक्लोज्ड डेक टेकन एज फ्रीबोर्ड डेक जो कम से कम मोल्डेड डेप्थ पे होना चाहिए. we are going to take it as molded depth, not 85%. दिस इज मोल्डेड डेप्थ पे हम 4.5 पे कंटिन्यूस हो, एक बल्कहेड से कंटिन्यूस हो एंड अथवार्ड शिप में कंटिन्यूस हो, तो फिर हम लोग उसको हम लेंगे एज फ्रीबोर्ड डेक, और उसके ऊपर जो भी डेक हुआ उसको हम सुपर स्ट्रक्चर कंसिडर करके कैलकुलेशन लगाएंगे फॉर फ्रीबोर्ड. आई होप दिस इज क्लियर. फ्रीबोर्ड डेक, इस पे कोई क्वेश्चन? So we come to the next part, which is superstructure. अब as per load lines, superstructure ship पे standard ship पे कोई superstructure नहीं. As per load line rules, स्टैंडर्ड शिप पे कोई सुपर स्ट्रक्चर नहीं है। जो सुपर स्ट्रक्चर आएगा उसके लिए हमें फ्रीबोर्ड पे एडिशन मिल जाएगा। वी कैन ऐड, वी कैन रिड्यूस योर फ्री, नॉट एडिशन बट subtraction of freeboard. We can reduce freeboard if your superstructure is added, because that is going to give you reserve buoyancy. So freeboard में it's a structure of deck structure on the freeboard deck extending from side to side. That means it should extend from side to side of the ship. एक condition तो वो हो गया कि या तो वो side to side extend कर रहे हैं, या with the side plating or not going inboard of the shell plating by more than 4% of breadth. अगर वो side to side extend नहीं करते हैं तो कम से कम side to be not more than 4% of ship spread. तो इसका जो distance है अंदर में आने का 4% से ज्यादा नहीं है. Sides are not set inboard by more than 4% of ship spread. अगर हम total ship spread लें तो ये वाली और ये distance है 4% से ज्यादा नहीं हो शिप स्प्रेड का. नो रेस क्वार्टर डेक इज रिगार्डेड एज सुपरस्ट्रक्चर. पुराने जहाजों में मिडशिप अकोमोडेशन होता था, रेस फॉक्सल डेक होता, रेस पूप डेक होता था जहां क्रू क्वार्टर्स रहते थे. तो रेस पूप डेक को भी हम सुपरस्ट्रक्चर मानते हैं, छोटे जहाज पुराने टाइप. So race quarter deck is often associated with smaller ships with machinery space sited aft, and being proportionally larger in smaller ships, there is a tendency for ship to be trimmed by head when fully loaded. तो अगर ये नहीं होगा तो आपका जहाज डाउन बाय हेड हो जाएगा. So to prevent this, height of outermost holds may be increased to increase the dead weight aft, and this is achieved by raised quarter deck. So enclosed superstructure is enclosing bulkheads of efficient construction. Excess openings, if these in the bulkheads are fitted with doors complying with requirements of regulation 12. तो इन bulkheads में जो excess openings है इसके ऊपर वो weather tight होंगी, इसके नीचे अगर होंगी तो water tight होंगी. A bridge or poop shall not be considered enclosed unless access is provided for the crew to reach the machinery and working spaces inside the superstructure by alternative means which are available at all times when the bulkhead openings are closed. इसका मतलब है कि इसके नीचे ट्रंक वे होना चाहिए पीछे से आगे जाने के लिए. ट्रंक वे अगर नहीं है तो इसको हम एनक्लोज नहीं मानेंगे, अगर ट्रंक वे है तो इसको एनक्लोज मानेंगे. So the height of superstructure is least vertical height measured at the side from the top of the superstructure deck beam to the top of the freeboard deck beam. तो इसकी हाइट होगी यहाँ जो बीम लगी है उसके ऊपर से इसके ऊपर की जो इसके नीचे जो बीम लगी है उसके ऊपर तक, टॉप ऑफ द फ्रीबोर्ड डेक बीम. तो फ्रीबोर्ड जो डेक है लिखा है टॉप ऑफ द सुपरस्ट्रक्चर डेक बीम, तो इसके ऊपर से ये जो फ्रीबोर्ड डेक की बीम है उसके तक सुपरस्ट्रक्चर हाइट होगा. मतलब ये डेक के नीचे जो बीम लगी है उसके ऊपर से इस फ्रीबोर्ड डेक के नीचे जो बीम लगी है उसके ऊपर तक ये हाइट ऑफ सुपरस्ट्रक्चर. तो लेंथ ऑफ सुपरस्ट्रक्चर मींस लेंथ ऑफ द पार्ट ऑफ सुपरस्ट्रक्चर व्हिच लाइज विद इन द एल. मतलब जो आपके 96% के अंदर में है उसको हम मीन लेंथ ऑफ सुपरस्ट्रक्चर मानेंगे. इसके ऊपर थोड़ा सा और डिटेल है सुपरस्ट्रक्चर का, इसको पहले कर ले फिर सुपरस्ट्रक्चर करेक्शंस पे आएंगे तो फिर वो करेक्शंस कैसे कैसे कैलकुलेट होती है वो बाद में आएंगे. अभी सिर्फ डेफिनेशंस का. फ्लश डेक का मतलब है स्टैंडर्ड शिप जिसके ऊपर कोई सुपरस्ट्रक्चर नहीं है. Weather tight का मतलब है any sea condition where water will not penetrate the ship in one direction. मतलब बाहर से अंदर, अंदर से बाहर जाने को weather tight नहीं बोलेंगे, बाहर से अंदर को weather tight बोलेंगे in any sea condition. Water tight means अंदर से बाहर ना जा सके और ना बाहर से अंदर आ सके, both directions. वो water tight हो. That is when your ship is submerged, तो उसके अंदर पानी नहीं जाएगा उसके ओपनिंग्स में. अगर वेदर टाइट है तो ओपनिंग से जा सकता है, अगर सबमर्ज हो गया सिंक कर रहा है तो पानी जा सकता है. लेकिन समुंदर अगर सी वॉश हो रहा है या ग्रीन सीज आ रहा है, उसमें पानी नहीं जाएगा इन एनी सी कंडीशन। तो हम आते हैं डेक लाइन क्या है। तो ये वाली शीदिंग दी गई है डेक लाइन के ऊपर, यहाँ कोई शीदिंग नहीं है, स्टील की है, और अगर ये वुडन शीदिंग दी गई है तो हम ऊपर से लेंगे इसकी डेक लाइन। अगर यहाँ कोई स्टील स्टील है सिर्फ, तो फिर हम इसके ऊपर से लेंगे, अगर हम लकड़ी भी लगी है तो लकड़ी के ऊपर लेंगे। तो deck line is a horizontal line marked amidships on each side of ship. An upper edge shall normally pass to the point where the continuation outward of the upper surface of freeboard deck intersects the outer surface of the shell plating. जहाँ intersect कर रहा है वहाँ। तो deck line basically 25 mm thickness होती है, इसकी चौड़ाई होती है 300 mm midships पे होगी। However, when the deck line may be placed within a reference to another fixed point on ship, on condition that the freeboard is corresponding corrected, the reference point location and identity of freeboard deck is clearly indicated if there is a rounded radius shear streak. तो यहाँ आपकी shear streak लगी तो उसमें करेक्शन लगी ये वाले, ये रेडियस है तो इस पे हमने करेक्शन लगाई और यहाँ हमने फ्रीबोर्ड डेक मार्किंग ये करेक्शन लगा दी। अगर ये रेडियस, अगर ये सीधा है तो इसके ऊपर लगा, अगर ये राउंडेड है तो फिर हमने इससे ये डिडक्शन लगा के करेक्शन यहाँ फ्रीबोर्ड डेक मार्क किया। अब ये आपके बेसिकली लोड लाइन मार्किंग है, जहाँ ये आपकी डेक लाइन आ गई, ये आपका प्लिम्सॉल मार्क आ गया, ये आपका समर ड्राफ्ट आ गया, असाइन समर फ्री बोर्ड, ये समर फ्री बोर्ड है, ये आपका फ्रेश वाटर लांस आ गया, तो ये आपका फ्रेश वाटर है, फिर ये ट्रॉपिकल फ्रेश है, इन दोनों के बीच में 540 है, 230 यहाँ है, एंड इन दोनों के बीच का जो डिस्टेंस है दैट इज एक्स, दैट इज समर ड्राफ्ट बाय 48, और समर एंड विंटर के बीच में भी एक्स इज समर ड्राफ्ट बाय 48 डिस्टेंस है। अब ये क्यों है इसका भी कैलकुलेशन निकला नहीं है। एनीबॉडी नोज ये समर ड्राफ्ट बाय 48 क्यों है एक्स? ये फॉर्मूला मुझे अभी मिला नहीं है कहीं, इसको मालूम है कि वाई एक्स इज समर ड्राफ्ट बाय 48? तो ज्यादा कुछ रिसर्च कर रहा हो तो उसको मालूम हो तो बता देना, भाई हमको भी कुछ जानकारी चाहिए, तो आप लोगों को अगर जानकारी हमें बता देना, एक्स वाई इट इज समर ड्राफ्ट बाय 48। टिम्बर में आपका फ्री बोर्ड कम हो जाता है, देखो अगर आप देखो फ्री बोर्ड कम हो जाता है, वाई फ्री बोर्ड कम हो जाता है आपको पता है ना, वाई फ्री बोर्ड इसमें रिड्यूस हो जाता है टिम्बर में। यहाँ देखो ना, इसमें फ्री बोर्ड ज्यादा है, समर फ्री बोर्ड इसमें इतना है, यहाँ समर फ्री बोर्ड इतना ही है, क्यों? ऐसा क्या रीजन है कि इसमें समर फ्री बोर्ड इतना ज्यादा है और इसमें टिम्बर में समर फ्री बोर्ड कम है? क्या रीजन है? नहीं मालूम किसी को? बड़ा
टिम्बर
जनरल क्वेश्चन।
more reserve buoyancy.
रिजर्व बॉयंसी ज्यादा है, सीधी बात है, ज्यादा रिजर्व बॉयंसी है, इसीलिए इसका फ्री बोर्ड कम है, और ये आगे मार्क होगा, ये पीछे मार्क होगा, ये आपके प्लिम्सॉल मार्क के आगे मार्क होगा और टिम्बर वाला पीछे मार्क होगा। अब आ जाते हैं व्हाट इज द कंडीशंस ऑफ असाइनमेंट। तो आपकी स्ट्रक्चरल स्ट्रेंथ इतनी होनी चाहिए कि आप built and maintain in conformity with the requirements of class recognized by the administration। आपके जो मास्टर के पास जो इंफॉर्मेशन है वो होगा कि मास्टर शुड बी सप्लाइड विद सफिशिएंट इंफॉर्मेशन इन अप्रूव्ड फॉर्म। द फॉर्म शुड बी अप्रूव्ड बाय द क्लास, अप्रूव्ड बाय योर class, your flag state, enable him to arrange for loading and ballasting in such a way to avoid creation of unacceptable stresses, provided that this requirement need not apply to particular length design of class ship where the administration consider unnecessary। एडमिनिस्ट्रेशन मतलब फ्लैग स्टेट अगर उसको अननेसरी समझता है तो नहीं जरूरत है, अगर अदरवाइज इट शुड बी अप्रूव्ड बाय द फ्लैग स्टेट। बहुत छोटा जहाज है उसको अननेसरी समझता है तो फिर वो उसको डिस्कार्ड कर सकता है, उसमें वो मैंडेटरी नहीं मारे, अदरवाइज it is mandatory to be approved by the flag state. Number two is every ship which is not required under the International Convention of Safety of Life at Sea is supposed to undergo an inclining test upon completion shall be inclined. तो inclining test कब कब होता है, ये आप लोग ने स्टेबिलिटी में किया है, ये कब कब होता है? Should be inclined and actual displacement position of CG shall be determined for the light ship condition. Should be supplied for the use of the master with such reliable information and an approved form to be enabled to for rapid and simple process like obtain accurate guidance for stability under all conditions likely to be encountered in normal service. Carry out on board at all times its approved stability information together with evidence that it has been approved by your flag state. अगर एडमिनिस्ट्रेशन अप्रूव करता है, have its inclining test on completion dispense with provided basic stability data is available from the inclining test of sister ship. अगर वो फ्लैग स्टेट अप्रूव करता है कि आपको इंक्लाइनिंग टेस्ट नहीं करना और आपके पास सिस्टर शिप की इंक्लाइनिंग टेस्ट रिपोर्ट है और वो सेटिस्फाइड है, तो फिर उसको वो कह सकता है यू डोंट रिक्वायर इट, अदरवाइज यू रिक्वायर अ इंक्लाइनिंग टेस्ट रिपोर्ट. And it is shown to the satisfied administrator reliable stability information can be obtained from such basic data of inclining test of sister ship. Then अगर उसने अप्रूव किया कि नहीं चाहिए तो फिर नहीं चाहिए, अदरवाइज चाहिए. The code of intact stability for all types of ships covered in IMO details or specifically the information that is provided to the master of all ships for stability calculation to ensure that ship is safe. अब आपका स्ट्रक्चरल कंडीशंस क्या है? अब कंडीशंस क्या है इसमें? बल्कहेड जो होंगे एक्सपोज्ड एंड्स ऑफ सुपरस्ट्रक्चर के, दे विल बी ऑफ एफिशिएंट कंस्ट्रक्शन. जो भी एक्सेस ओपनिंग्स है बल्कहेड की एट द एंड्स ऑफ एनक्लोज्ड सुपरस्ट्रक्चर शैल बी फिटेड विद स्टील वेदर टाइट डोर्स. तो सुपरस्ट्रक्चर बिकॉज एनक्लोज्ड सुपरस्ट्रक्चर आपके फ्रीबोर्ड डेक के ऊपर है, तो ये वेदर टाइट डोर होगा. That will be provided equivalent bulkhead strength when closed, and this must be sealed with gaskets and clamping device capable of being operated from both sides, and their sill should be 380 mm above the level of deck. Now what is sill? So suppose ये आपका enclosed superstructure है और अगर आपका suppose ये weather tight door है, तो ये जो हम जो फांद के निकलते हैं डोर के बाहर, ये हाइट को हम सिल कहते हैं, क्योंकि हमारा जो वेदर टाइट डोर है फ्रीबोर्ड डेक के लेवल पे नहीं है कि फ्रीबोर्ड डेक तक आ जाए, वो इसलिए ताकि अंदर पानी ना जाए आपके फेसेस पे. तो ये सिल हाइट होती है, दैट शुड बी 380 mm. अब वो क्या क्या है अलग अलग स्पेसेस में सिल हाइट अलग अलग है फॉर योर वेदर टाइट डोर्स. बेसिक है 380 mm above the freeboard deck. This is the sill height. अब इसमें दो पोजीशन है आपके हैचवेज के, वेंटिलेटर्स के. एक्सपोज्ड फ्रीबोर्ड एंड रेस क्वार्टर डेक एंड अपॉन, ये पोजीशन 1 है विच इज 25% आफ्ट ऑफ द फॉरवर्ड परपेंडिकुलर. ये वाला, ये आपका पोजीशन 1 है. फॉरवर्ड परपेंडिकुलर से 25% पीछे तक इज योर पोजीशन 1. ये अगर आप देखो यहां तक आपका पोजीशन 1 है. तो पोजीशन 1 is the exposed freeboard and raised quarter decks and upon exposed superstructure forward of a point located at quarter of the ship's length from forward perpendicular. अब इसमें हम ये डेक लेंगे, नॉट पूप डेक बट ये डेक फॉरवर्ड परपेंडिकुलर से 25% पीछे. पोजीशन 2 इसके पीछे जो भी अबाफ्ट है उसको हम पोजीशन 2 लेंगे. अब इसमें हाइट ज्यादा होती है एज कम्पेयर टू दिस हाइट, क्योंकि यहाँ आपकी ग्रीन सीज ज्यादा आती हैं एज कम्पेयर टू आफ्ट ऑफ 25%. तो ये आपका कंडीशन असाइनमेंट आएगा पोजीशन 1 एंड 2, जहां आपके हैचवेज, डोरवेज एंड वेंटिलेटर लगेंगे. क्या क्या हाइट पे लगेंगे अब उसको हम डिस्कस करेंगे. सो ये जो आएगा वो 3/4 डिस्टेंस आएगा एल का. ये वाला आएगा 25% ऑफ एल आफ्ट ऑफ फॉरवर्ड परपेंडिकुलर. अब इनमें क्या क्या है हैच कोमिंग जो होंगी. पोजीशन 1 में 600 mm अबव डेक होंगी। अगर आप देखो यहाँ हैच कोमिंग्स जो है इसके ऊपर 600 mm अबव डेक, ये वाला ये हाइट होगा 600 mm अबव डेक। एंड पोजीशन 2 में वो होगी 450 mm above deck. If these are equivalent superstructure height and strength, and average width of at least 60% of ship breadth at their point of location shall be regarded as trunk, and additional reserve buoyancy shall be afforded by them shall be taken into account for calculation of freeboard, which is usually the case. अब इसको, if these are of equivalent superstructure height and strength, अगर यही आपके कोमिंग्स इनकी विड्थ है 60% ऑफ शिप्स ब्रेथ एट द पॉइंट ऑफ लोकेशन, देन इनको ट्रंक वे में कैलकुलेट कर सकते हैं, और जो इनमें बेसिकली एडिशनल बॉयंसी ये दे सकते हैं रेज्ड हाइट ऑफ आपकी हैच कोमिंग्स। अगर ये 60% ब्रेथ ऑफ मैक्सिमम ब्रेथ है तो उसको हम ट्रंक वे में ले सकते हैं। If they are of God equivalent, अगर यही कोमिंग की इक्विवेलेंट सुपरस्ट्रक्चर हाइट और स्ट्रेंथ है और एवरेज विथ 60% शिप ब्रेथ है तो उसको हम ट्रंक वे ले सकते हैं फॉर एडिशनल बॉयंसी विच दीज गिव। रिजर्व बॉयंसी ये ज्यादा देंगे तो उसको हम कैलकुलेशन में ले सकते हैं, जिसके कारण हमारा फ्री बोर्ड रिड्यूस हो जाए। हम ट्राई कर रहे हैं कि फ्री बोर्ड बढ़े नहीं बट घटे, सो दैट हम कार्गो ज्यादा कैरी कर। तो ये आपके हैचवे कोमिंग इन पोजीशन 1 एंड 2। अब आता है कि इनकी स्ट्रेंथ कितनी है। इन पोजीशन 1 ये हैचवेज की स्ट्रेंथ कितनी है, हैच कवर्स की स्ट्रेंथ कितनी है। तो हैच कवर्स की पोजीशन 1 में स्ट्रेंथ इतनी है कि 1.75 टन पर मीटर स्क्वायर मीटर क्यूब ऑफ वाटर इट कैन सस्टेन। तो जो यहाँ पानी आएगा जिस फोर्स से आ रहा है, इट कैन सस्टेन 1.75 टन पर मीटर क्यूब ऑफ वॉल्यूम ऑफ वाटर the onslaught on your hatch cover. पोजीशन 2 में ये 1.3 है, क्योंकि जो पानी यहाँ से पीछे तक आएगा वो इतना ज्यादा स्ट्रॉन्ग नहीं होगा, यहाँ ज्यादा स्ट्रॉन्ग होगा, यहाँ कम स्ट्रॉन्ग होगा, इसलिए 1.3 यहाँ 1.75। देन आता है मीन्स फॉर सिक्योरिंग हैच कवर शैल बी ऑफ ensuring weather tightness in any sea condition, and hatch cover will be subject to test at initial and subsequent service to ensure effective arrangements। मतलब इसमें जो टेस्ट होंगे वेदर टाइटनेस के, एक तो होस्ट टेस्ट होगा, एक आपका लाइट टेस्ट होगा, एक आपका अल्ट्रावायलेट टेस्ट होगा। सो ऑल दीज टेस्ट विल प्लस एक चॉक टेस्ट होगा। 4 टेस्ट होते हैं फॉर चेकिंग योर इफेक्टिवनेस ऑफ वेदर टाइटनेस ऑफ हैच कवर। और अगर उसका हैच कवर जो हैच बेसिकली पैकिंग है वो मोटी नहीं, वो बेसिकली टफ नहीं होनी चाहिए। इट शुड बी नॉट टू सॉफ्ट नॉट टू हार्ड। इसके ऊपर पेंट नहीं करना है, और अगर ये बहुत हार्ड हो जाती है तो कम से कम 1 मीटर लेंथ चेंज होगी, उससे कम नहीं, कम से कम 1 मीटर लेंथ चेंज होगी। अदरवाइज आपको एंटायर चेंज करनी करो, लेकिन कम से कम 1 मीटर चेंज। Now machinery space opening in position 1 and 2 shall be properly framed and efficiently enclosed by steel casing. If the casing themselves are not protected by other structures, then the strength will be specially considered. It is usual for many ships to gain access to the engine room from inside protective superstructure. So that is your space opening 1 and 2 में इनकी फ्रेमिंग क्या होगी, एफिशिएंटली क्लोज होगा। इसकी डिटेल्स हम इतनी ज्यादा इसमें नहीं करेंगे। Now miscellaneous opening जो फ्रीबोर्ड एंड सुपरस्ट्रक्चर डेक पे है, जो बेसिकली आपकी मैन होल्स हैं या फ्लश स्कटल्स हैं, तो मैन होल्स बेसिकली आपके एलिप्टिकल होते हैं, फ्लश स्कटल्स का शेप अलग हो सकता है। फ्लश स्कटल्स बेसिकली आपके बेसिकली स्कटल जो होते हैं वो पोर्ट होल्स होते हैं। तो अगर वो फ्रीबोर्ड डेक के साइड में लगे हैं इन पोजीशन 1 एंड 2 विद सुपरस्ट्रक्चर डेक, तो फ्लश स्कटल्स ये सारे वाटर टाइट होंगे। Other than enclosed superstructure, they shall be closed by substantial cover capable of making watertight. Unless secured by closed space bolts, the cover shall be permanently attached. Openings in freeboard deck other than hatchways, machinery space opening, manhole, and flush curtains shall be protected by enclosed superstructure or deck house or companionway of equivalent strength. and weather tightness, क्योंकि जो भी डेक के ऊपर आया वो weather tight. Now position 1 में deck of sills in the doorways shall be 600 mm and position 2 में 380 mm. ये जो डायग्राम किया था, ये सिल हाइट होगी पोजीशन 1 में 600, पोजीशन 2 में 380. ये सब याद करनी पड़ेगी आप. पोजीशन 1 में क्या हाइट है, पोजीशन 2 में क्या हाइट है, पोजीशन 1 में आपका हैच कवर का क्या स्ट्रेंथ होगा, पोजीशन 2 में हैच कोमिंग्स का क्या हाइट होगा, पोजीशन 2 में क्या होगा, ये सब आपको याद करना है. अब आता है वेंटिलेटर. So ventilators in position 1 or 2 spaces below freeboard or superstructure deck shall be steel coaming with at least 900 in position 1. इतनी हाइट होगी वेंटिलेटर की, and 760 in position 2 above the deck. और इसमें जो ओपनिंग्स होंगी that will be provided by weather tight closing appliances. If the ship is not more than 100 meter in length, they shall be permanently. तो जो भी आपकी क्लोजिंग अप्लायंसेस होंगी, अगर वो 100 मीटर से ज्यादा है तो परमानेंटली अटैच नहीं होंगी, वो साइड में रहेंगी. लेकिन जो मोर देन 100 मीटर्स इन लेंथ है वो परमानेंटली अटैच्ड. If the coamings extend more than 4.5 meters above deck in position 1, then they do not need to be fitted with closing arrangements in the ventilator. और अगर कोमिंग की हाइट 2.3 है इन पोजीशन 2 और इसके ऊपर आपका वेंटिलेटर लगा है, तो फिर उसमें भी आपकी क्लोजिंग अरेंजमेंट नहीं होगी अनलेस फ्लैग स्टेट बताता है. अब आता है एयर पाइप्स टू द बैलेस्ट एंड अदर टैंक्स एक्सटेंडेड अबव फ्रीबोर्ड और सुपरस्ट्रक्चर डेक शैल बी सब्सटैंशियल करेक्शन construction and extend up to height above the deck at least 760 mm on freeboard deck and 450 mm in the superstructure deck. And इनमें permanently closing means होने चाहिए एयर पाइप में. अभी हमने वेंटिलेटर की बात की थी, अब एयर पाइप्स की जो बात कर रहे हैं, इनमें पोजीशन 1 2 नहीं है. इनमें अगर आप देखो कोई पोजीशन 1 2 नहीं है. इनमें दिया है कि अगर वो डेक के ऊपर है तो उसकी हाइट 760 mm होगा, एंड अगर वो सुपरस्ट्रक्चर डेक पे है वो 450 mm होगा, और इनके साथ परमानेंटली अटैच मींस ऑफ क्लोजिंग होगी एयर पाइप में. नॉर्मली एयर पाइप्स के अंदर आपका बॉल होता है so that पानी अंदर ना आए, so that becomes a non return valve जो permanently means of closing. अब आते हैं what are cargo ports. So cargo ports and other similar openings in ship side below the freeboard deck shall be kept to a minimum number compatible with the design and proper working of ship. Doors may be designed to ensure structural integrity and watertightness. The lower edge of such opening shall be not below the line drawn parallel to the freeboard deck, which is the lowest point level with the upper edge to the uppermost load line. That's for the cargo ports. आते हैं discharges. So discharges shall be fitted with efficient and accessible means of preventing water from passing inboard. Normally, each separate discharge shall be one automatic non-return valve with positive means of closing it from position above freeboard deck. Where, however, the vertical distance from summer load line to the inboard end of the discharge pipe exceeds 0.01 L, the discharge will have 2 automatic non-return valves without positive means of closing. Otherwise, एक होगा with positive means of closing, otherwise 2 होगा अगर उनके बीच में vertical distance कम हो गया, exceed ज्यादा हो गया, 0.1 L से ज्यादा हो गया, then 2 automatic non-return valve होगा without positive means of closing, provided the inboard valve is always accessible for examination under service conditions. अगर वो vertical distance exceed कर रहा है 0.02 L, then single automatic non-return valve को भी accept कर सकते हैं. अब आता है scuppers and discharge pipes originating at any level penetrating the shell more than 450 mm below freeboard deck or less than 600 mm above the summer load line shall be provided with non-return valves at the shell. अगर इसमें पाइपिंग सब्सटैंशियल थिकनेस की है, देन वे वाल्व की जरूरत नहीं होती. and the valve may be omitted. All shell fittings and valves required by regulation 12 shall be of steel, bronze or approved ductile material, and pipes जो होंगी approved equivalent material की. Side scuttles जो भी आपके port holes हैं, to spaces below freeboard deck and or spaces within the enclosed superstructure shall be fitted with hinged inside deadlights arranged so that they can be effectively closed and secured watertight. Now what is deadlight? आपको एक बार पहले ही बताया था कि जब आपके पोर्ट होल्स बने होते हैं, ये पोर्ट होल आपका बना हुआ है, इसके ऊपर अगर हमने एक कवर लगा दिया सो दैट लाइट ना आए, और इसमें हमारे क्लोजिंग मीन्स है ऊपर और नीचे पोर्ट होल के ऊपर एक कवर है, जो आपके पोर्ट होल के ऊपर देखा होगा ये कवर होता है, उसको एक्स्ट्रा प्रोटेक्शन देता है. तो दैट इज नोन एज डेड लाइट. इसका मतलब आपने इसको बंद किया तो आपके कमरे में कोई लाइट नहीं आएगी. दैट इज नोन एज डेड लाइट. जैसे हम लोग पर्दा लगाते हैं, पर्दे लाइट नहीं आएगी ना, तो आपके कैबिन में तो पर्दा है, लेकिन पोर्ट होल्स के आगे आपका डेड लाइट दिया जाता है, तो टाइप बिल्कुल लाइट ना. दैट इज डेड लाइट. तो फ्रिंग पोर्ट जो है, फ्रिंग पोर्ट क्या चीज है वो आपको बता देते हैं. व्हाट इज अ फ्रिंग पोर्ट? ये बुलवर्क के नीचे होता है फ्रिंग पोर्ट. तो सपोज ये आपका मेन डेक है और इसके ऊपर हमने एक बुलवर्क लगाया है, ये लगाया, उसके बाद आपकी रेलिंग्स आ गई, यहाँ आपकी रेलिंग्स आ गई, ये रेलिंग्स आ गई आप. अब बुलवर्क के नीचे जो पानी हो तो इकट्ठा हो जाएगा, तो उसके नीचे एक ओपनिंग होती है ऐसी. अब इससे क्या पानी नीचे से निकल सकता है, पानी इकट्ठा नहीं होगा, क्योंकि अदरवाइज बुलवर्क हो जाएगा तो पानी डेक पे इकट्ठा हो जाएगा, तो दैट कैन अफेक्ट योर स्टेबिलिटी. इसलिए आपके ज्यादातर रेलिंग्स लगी है तो कि पानी निकल जाए. कई बार इसमें हिंज लगी होती है, कई बार ये ओपन रहता है, तो इसको हम कहते हैं फ्रिंग बोर्ड. दिस इज अ फ्रिंग बोर्ड ऑन डेक. So freeboard shall be provided in bulwarks to allow for rapid freeing of water from deck. Required freeboard area is specified in number formula. ये अलग formula है इसका. Then आता है protection of crew should be ensured for the provision of efficient guardrails or bulwark which are to be fitted on all exposed freeboard from the at the superstructure deck. They should be at least 1 meter in height from the deck. In the case of guardrails, the opening below the lowest course of guardrail shall be not exceeding 230 mm and the rail shall be not more than 380 mm apart. Special provision including lifelines, जो safety lines लगी होती हैं deck पे, shall be fitted for allowing crew safe access from and to all parts of the ship during normal operation, which includes access in the way of deck cargoes also. तो अभी तक ये करा दिया है. अब we'll come to टाइप ए, टाइप बी एंड टाइप ये B100 B60 सब करेंगे, एंड व्हाट इज परमेबिलिटी, ये सारा करेंगे. आज के लिए तो काफी हो गया. देन आपका इनिशियल लोडिंग कंडीशन क्या होगा, देन इसमें कंडीशन इक्विलिब्रियम क्या है, ये आपका डैमेज स्टेबिलिटी रिक्वायरमेंट्स ऑफ शिप आ जाता है. देन टाइप ए क्या है, then distinction between type A and type B, and then your B60 B100 क्या है, then B60 का additional freeboard requirements and B100 का additional requirements. We will not do यहाँ टिम्बर भी आएगा, ये सब हम करेंगे. इसके बाद टिम्बर का हम लोग छोड़ देंगे, टिम्बर नहीं करेंगे. we'll do all that. शेयर का कैलकुलेशन, ये कैलकुलेशन, एंड बी का कैसे कैलकुलेशन करेंगे, टिम्बर फ्रीबोर्ड को छोड़ देंगे. तो काफी इसमें रट्टा मारना पड़ता है टनेज में, लोड लाइन में काफी रट्टा मारना पड़ेगा आप लोगों को. कई बार क्वेश्चन 25 का आता है, कई बार 50 का आता है, डिपेंडिंग. 25 का तो आता ही है, बट यहाँ है कि चॉइस है तो आप लोग छोड़ देते हो ज्यादातर. ठीक है, सो we'll take a break now and then we'll meet again. We got 2 more classes this week, so we'll do all that. In case you have any more questions, December batch for your exam, then you can ask. Because अभी सारे papers कर लिए हमने, अभी revision नहीं हो रहा आपका. ठीक है. So we'll meet in the next class tomorrow or maybe day after tomorrow. We'll meet. Good afternoon. So we'll continue with your tonnage. So how do you assign this type A freeboard after you get from tabular? So basically, tabular freeboard is given in regulation 28 of this Loadline rules, and you'll get your tabular freeboard basis your length of the ship. Now, tabular freeboard is basis standard ship. Now, standard ship, as per load line, has got various characteristics. So they've got 5 characteristics which we take into account. First is your block coefficient, which should be 0.68. Now that is basis standard ship, and the tabular freeboard is basis standard ship. So for a standard ship, block coefficient is supposed to be 0.68. L by D, that is length to depth ratio, is equal to 15. This parameter is taken for a standard ship. For a standard ship, there is no superstructure. That means whatever superstructure we get, we have that correction. Number 4, parabolic shear. Shear basically is your upward curvature of the uppermost continuous deck in the 4.5 direction. So parabolic shear of the freeboard deck attained a particular height at the forward and aft perpendiculars as prescribed by the formula for the shear as per Simpson's rules is dependent on the length of the ship. Forward shear normally is twice of aft shear. And number 5, these are the specific characteristics of standard ship. अभी इसका question कभी आया नहीं है कि as per tabular freeboard describe the or write down the specific characteristics of a standard ship. Then you have to answer this. This is the question. Now this question has not come, but if it comes, then you have to write about these features. Now the minimum bow height above the load water line is as per formula. We will come to that formula later. What is the formula for bow height? As per CB and length of ship. Now, depending if your block coefficient is less or more, so this thing has to be added, freeboard has to be added or subtracted. That is what you have to do. So the corrections will be added or subtracted basis the standard features. If you are varying from these standard features, then your corrections will be added or subtracted. So first we come to the correction of block coefficient. So standard ship will have a block coefficient of 0.68. If your block coefficient is more than this, then the correction will be achieved by tabular freeboard into CB plus 0.68 by 1.36. So that means your freeboard has to be increased in case your block coefficient is more. Now why it is so? Why your block coefficient, if it is more than 0.68, like suppose your freeboard for your VLCC, your freeboard is your CB is 0.85. So that means this vessel is going to have more sinkage, because the more is your block coefficient, the more is the vessel sinkage. So if you have a standard vessel, which is this rounded vessel, maybe a general cargo ship, then the sinkage will not be as much as compared to a non-standard ship where your block coefficient is more than 0.68. So in that case, you have to increase the freeboard because the sinkage is more. So larger CV means increases the underwater volume. So when your underwater volume increases, then the freeboard must be increased to so that your reserve buoyancy amount to same percentage of greater displaced volume, as this will be CB 0.68. Because you see what happens if your underwater volume is more, so what volume displaced will also be more. When the volume displaced is also more because of more underwater volume, then the water vessel is going to sink more. If it is going to sink more, so to compensate that, we have to increase the freeboard. So that is the reason why if you got more than 0.68 freeboard, you have to increase the freeboard with the correction. That is number one. So you have to explain this with your correction for block coefficient. You have to explain with this diagram, the formula, why freeboard is increased for non-standard ships which are greater than 0.6. Now we come to correction for depth. So that means L by D is equal to 15. So if L by D is less than 15, then the freeboard is to be increased, which is normal the case. So L by D will not be more than 15. It is right. It is actually less than 15 for other ships. So L by 15 is so depth basically is more and length is less. So if you have L by D is less than 15, we increase the freeboard. But in case you have L by D more than 15, then your freeboard has to be decreased. But you can only decrease freeboard if L by D is greater than 15 if the conditions are here. The ship has an enclosed superstructure covering at least 60% length amidships, a complete trunk, or a combination of detached enclosed superstructure and trunks which extend all fore and aft. So freeboard can be decreased only if your L by D is more than 15 plus ship has enclosed superstructure covering 60% of length amidships, a complete trunk, or a combination of detached enclosed superstructure and trunks which extend fore and aft. Then you can have the freeboard decrease. Otherwise, even if you have L by D greater than 15, you can't decrease the freeboard. Now, why? Why is the reason that if L by D is less than 15, we have to increase the freeboard? And why with L by D is more than 15, we can decrease the freeboard? So these are the two diagrams. If L by D is less than 15, so suppose your length to depth, length is less and depth is more. So if you have one compartment flooded, so you will have greater sinkage and loss of freeboard in this kind of vessel, because the reserve buoyancy by the other compartments will not compensate for the loss buoyancy of this compartment. So there you have to increase the freeboard to compensate for the loss of buoyancy, which should be at least equal to This loss of buoyancy should be equal to the reserve buoyancy of these two intact compartments. Now, in case of when L by D is greater than 15, suppose this compartment is flooded. So you have a loss buoyancy, volume loss buoyancy, this one, and the reserve buoyancy gained by the other compartments is this one. So now this will be more than this. The volume of buoyancy gained by the other compartments will be more than the loss by one compartment. So there you can decrease the freeboard, provided, of course, you have enclosed superstructure covering 0.6 L, complete trunk, or a combination of detached enclosed superstructure and trunk, which extend 4.5. So the ship in figure 26.15 are considered an amidships compartment extending full depth of the hull where flooded due to damage or underwater damage. Ship 1 will experience more sinkage and loss of freeboard as compared to ship 2, because here you have more buoyancy gained as compared to lost. So these were the two conditions for correction. Now we have another correction, which is position of deck line. So now if the actual depth of the upper edge of the deck line here, upper edge of the deck line is greater or less than depth for freeboard, the difference, if greater, shall be added and less should be deducted from freeboard. So suppose this distance, that the actual depth to the upper edge of the deck line, is greater than depth for freeboard or D, then that difference will be added to the freeboard here, and it will be added to the freeboard. So your freeboard has to be increased. But in case the depth or D is less than the depth for freeboard, if the actual depth to the upper edge of this deck line is less than the depth for freeboard, that means D is more than actual depth, then you can deduct from the freeboard. So that correction is there. So normally, if your deck line is supposed to be, this is the shear, if it's rounded shear, then the deck should be here. So that correction is given here. That correction should be there for the suppose D is more than upper edge of this the actual depth, then you have to add that correction. Otherwise, it should be subtracted. Now we come to number 4, correction for superstructure and trunk. Then you have correction for shear, and then you have correction for bow height. So standard ship, as we had seen the condition of standard ship having 5 basic requirements, which we have done is block coefficient 0.68, L by D 15, no superstructure, parabolic shear, minimum bow height. So we are considering no superstructure as the standard ship. So every ship will have a superstructure, so correction will be deduct. Whatever superstructure you have, your reserve buoyancy is increased. So your freeboard will be deducted from your tablet freeboard. So the standard ship has no superstructure. Enclosed superstructure of significant height are important in providing reserve buoyancy above the freeboard. So the freeboard deductions are allowed for effective enclosed superstructure length as a proportion of the ship's freeboard length, and the deduction in freeboard allowed is determined by number of formula and tables. So that formula is not here, but we'll do that formula separately. What other notes, we'll do that formula there. So see where the formula is. So this is the freeboard correction formula for superstructure. So first we'll do this correction and then we'll go to those other nodes. So where the effective length of superstructure is E and the trunks that meet the requirement of subpart D of this part is 1L, the minimum sum of freeboard will be corrected by subtracting half HS. So we'll come to what is HS and all that. The formulas are given as per Simpson's rules here. 1331, 1331. Those factors are there. Standard shear profile here. No, this is shear correction. So that shear correction will be as per this Simpson's rule. This will be your percentage for correction of length of superstructure. Now, when the effective length of superstructure and trunk is less than 1L, freeboard may be corrected by subtracting a percentage of 1/2 of superstructure height, which is half your HS. Percentage is E by 2L into 1 by E by L into 100. That corrections are there. So that will be correct, eligible for correction of trunk. And trunk can be taken as superstructure if it is at least strong and stiff as superstructure. There is no opening in the freeboard deck in the way of trunk except small excess openings. Have hatch coamings and covers that meet requirements. Provide permanent working platform 4.5 with guardrails. Then your trunk can be eligible for corrections. Provide a permanent working platform 4.5 with guardrails. Provide 4.5 access with detached trunks and superstructure by permanent gangway. Your trunk should be at least 60% of the breadth of the ship in way of trunk and should be at least 0.6 L in length. If no superstructure is provided, then trunk should be 0.6 L. Then the trunk can be taken as superstructure. So Rule 33 defines the standard height of superstructure as per table. So standard height, raised quarterdeck in meters, 30-meter length less is 0.9. All of the superstructure 1.8. 75 here is 1.2. That's the height of raised quarterdeck. And all other superstructure 1.8. 125 meters or more, it is 1.8 raised quarterdeck, and 2.3 is the other height of the superstructure. So any between 75 to 125 you will have by interpolation. Now regulation 36 allows a reserve buoyancy of trunks to be taken into consideration also, and the conditions, as I said, will be these conditions when the trunk can be taken as superstructure for correction. So 7 points are there. So not precisely defined, the reserve buoyancy of trunk to be taken in consideration also, although not precisely defined, regulation for trunk may be regarded as structure having equivalent bulkhead strength as the superstructure that opens directly into space below the freeboard deck and having average width of at least 60% length of ship at the position in which they are situated. Hatch coaming shall be of heights equivalent to that of standard height of the superstructure as determined by the table. May be considered as trunks provided additional reserve buoyancy provided for the ship. Details of regulation 37, deduction of freeboard that will be permitted for effective length of superstructure and trunks. It should be deduction in freeboard since the standard has no superstructure. So whenever you have a superstructure, that height will be taken for deduction in freeboard. So those formulas are there. Now we have shear profile. So shear is basically, suppose white is taken as a standard shear profile of the vessel. That's how the standard shear, the white section is taken. If it is excess, more shear, then your freeboard has to be deducted because more reserve buoyancy is there. And if there is less than the white one, so if you are in the next section, this one, the gray one, then that means your shear is less, so that means your reserve buoyancy is less, so your additional freeboard to be there. So correction to be added as per the Simpson's rules, which are these. You have these formulas calculated and then you find out what is your correction for the shear. So you have that formula aft perpendicular is taken 25 by into L by 3 plus 10 in mm. Your factor is 1, L by 6 from aft perpendicular 11.1 here. The factor is 3 where you multiply, and then L by 3 from aft perpendicular 2.8 into L by 3 plus 10. And factor is 3 for multiplication. Midship is taken as midship is 0. So factor 1, so again this factor will be 0. So you add that and then you add those factors and find out the correction in mm. L by 3, 5.6 into L by 3 plus 10 to factor 3, L by 6 from forward perpendicular. So you're taking the distance from aft and then midships and then from forward to midships. So again, you multiply that and then you find mm, and then that's your shear correction. And if your shear is more than your standard profile, then you have to subtract from your freeboard and you get less freeboard. If you have less, then you add. Now, what are the benefits? What is shear? So shear is basically curvature of freeboard deck in fore and aft direction. So how high or low it is. Because why shear is required so that your shipping of seas from forward is reduced and aft is reduced. So aft is half because forward green seas are coming more as compared to the pooping part. So what are the benefits of shear? That is greater reserve buoyancy at the ends of the ship, particularly forward, ensuring good lift ahead. You have reserve buoyancy, so whenever the sea comes forward, you can lift easy because of reserve buoyancy. Reduce water shipped on deck. Reduces risk of foredeck being submerged after collision, thus improving survivability in the damaged condition. Helps maintain acceptable angle of heel and with the progressive down flooding takes place. Now, your tabular freeboard are based upon the standard shear profile, measured at 7 equally spaced stations, which we have done here. 7 stations. A process based on Simpson's rule of area estimation 1331, that is the rule, is applied separately to the shear measurements from aft perpendicular midships and then forward perpendicular midships to produce measures of effective shear aft and forward. Any deficiency in shear will result in increase in freeboard. Excess shear will have deduction in freeboard. So that amount is as per the formula. Then we come to correction for bow height. Now there are 2 ways of correction of bow height. One is when you have a raised bow height, or if you have a minimum shear at the distance where the minimum shear is achieved. So 2 conditions in that. You have to write both, not one condition. Normally you write only one condition and then the marks are cut. So in addition to the formula, you have to write both the conditions for correction of bow height. So minimum allowable bow height should be maintained when the vessel is floating to summer load line at the design trim. The assigned sum of freeboard for vessel must be increased if necessary, if your minimum bow height requirements are not met. Then your freeboard has to be increased. Because the bow height is required, because otherwise you'll be shipping seas and you are not draining seas. That means the water is going to come there. So that means the water collection will be there on deck. That way your additional displacement will be there with the water added. That means you're going to submerge. That's why in case your bow height is less, you have to add. Bow height is more, then you can subtract. So minimum bow height is in millimeters required at the forward perpendicular at the summer water line. 2 conditions here. When it is less than 250 and when it is greater than or equal to 250, the freeboard length or L. The first condition is less than 250. Minimum bow height will be 56 L into 1 minus L by 500. Now we take your block coefficient also into this value into 1.36 divided by CB plus 0.6 is where 0.68 is the CB for standard ship. So actual CB will be actual CB of the ship. Now, in case your freeboard length is greater than or equal to 250, then HB or minimum bow height will be 7,000 into 1.36 divided by CB plus 0.68, and CB in no case will be less than 0.68. So if the freeboard is calculated from considering previous corrections is less than the bow height, then the bow height minimum formula will be assigned as summer freeboard. So required bow height can be achieved in two ways. One is extending in this condition where your bow height is increased for length at least when you're fitting a superstructure here in the bow. So minimum bow height here should be at least 0.07 or 7% of L or LBP from out perpendicular. Second condition is by increasing your shear for at least 15% length from the forward curve. So either you're raising the bow height with the fitting superstructure or increasing bow height for certain distance by increased shear at least 0.15. So required bow height may be achieved by including shear, provided the shear extends at least 15% of L from the forward perpendicular, fitting a raised forecastle, provided such forecastle extend at least 7% or 0.07 L from the forward perpendicular. Both the diagrams are required. So the freeboard is calculated applies to ship when in salt water and assigned to the ship as its summer freeboard, and summer freeboard should not be less than 50 mm in any case. If the ship has hatches in a position 1 and not made from steel, then the summer freeboard shall not be less than 150 mm, ignoring the correction for the position of deckline. Then your tropical, winter, North Atlantic, and freshwater freeboards are then calculated after your summer freeboard is calculated. Now, how will you do the corrections for type B freeboard? So you are obtaining type B from your ship's tabular freeboard, which is regulation 28 as per the length. So if the ship qualifies for reduction in tabular freeboard, either 60 or 100, B60 or B100, then you will be applying your corrections as per the 6 corrections. These are additionals in case you have tabular freeboard for type B ships having wooden hatch covers. And there's a correction there. So if the ship has the hatch phase in position 1, then the freeboard which is not made of steel are made of wooden with tarpaulin. Then the tabular freeboard obtained from B will be increased by amount dependent on the length of ship. That is an other addition thing given as per 27.6. There, if you have wooden hatch covers, then your freeboard is to be increased as per the specification given basis length of ship. There's an addition to the 6 corrections for type B ships having wooden hatch covers. The second part for type B vessel is, in addition to the 6 corrections, if it is under 100 meters in length, not more than 100 meters, so less than equal to 100, and has enclosed superstructure, the total effective length E, which does not exceed 35% of the length, then the freeboard will be increased, mounting to 7.5 into 100 minus L into 0.35, that is 35% of ship's length, minus E, effective length of superstructure, divided by L in mm. So that will be increase in freeboard if your type B vessel is less than equal to 100 meters length. That this formula will be applied, will be added to your freeboard. So that addition of freeboard will be this amount. So shorter vessel likely to pitch more. Now why it is given? Why a shorter vessel? Why additional freeboard is given? There is an explanation given. A shorter vessel is likely to pitch more as it makes way through the water, and as such, the presence of superstructure forward and aft may be very important in minimizing the amount of water shipped on board. So that is why you have an increase in freeboard. For longer ships, over 100-meter length, they tend to pass through the waveform, and therefore the pitching will be less. So the tabular freeboard thus so far corrected now has the same correction as described previously for type A vessels applied to obtain the assigned sum of weight. So type A vessels, we have done 6 corrections. Type B vessels also 6 corrections. In case wooden hatch covers, you have to have additional freeboard as per the regulation 27.6. In case they are vessel less than equal to 100 meters in length, then you have addition in freeboard as per 7.5 into L 100 minus L into 0.35 minus E by L in mm. We will not do timber freeboards. Now we'll come to what are the load line certifications and surveys. So the ship must issue with a load line certificate, and with the ship certificate, international load line certificate, should must be in form prescribed. And the surveys here for load line will be initial survey. Whenever you're purchasing a ship or first time put in service after maybe manufacturing that ship or after your trials, sea trials or not, then you have to have initial survey. Renewal survey not exceeding 5 years, within 3 months of expiry. Annual survey within 3 months plus minus of the anniversary date of load line survey. And the endorsement will be done on your load line certificate after all the surveys are done. Purpose of validity of load line may be extended for a period of exceed 3 months for the purpose of allowing ship to complete voyage, just so that extension can be given after application. Now, how do you prepare a vessel for load line? So in load line, first thing is checked is your watertight integrity of this vessel. Is the hull watertight below your freeboard deck and weathertight above it? But for cargo tanks, the access should be watertight because those openings are cargo tank access are small. So there the cargo tanklets will be watertight. In all other cases, when they are general cargo containers, then it will be weathertight. So your checks before survey will be all your access openings at the ends of enclosed superstructure should be in good condition. All your dogs, clamps, and hinges should be free and greased. Gasket and other sealing arrangements should not show signs of perishing. Ensure that doors can be opened from both sides. Ensure that door labels such as to be closed to be kept in place. Check all your cargo hatch and access to holes for weather tightness. Securing device like your clamps, cleats, wedges to be in place. They should be well greased and adjusters to provide optimum sealing between hatch covers and compression bar on the coving. Replace your perished rubber seals as necessary. Hose test hatches to verify your weather tightness. Number 3 is your efficiency in securing of portable beams. That is for vessels which do not have those hydraulic mechanical opening of hatches or steel hatches. For wooden hatches, ensure that the hatch board are in good condition and that the steel binding hands are well secured. A minimum of at least 2 tarpaulins must be provided on each hatch. It must be in good condition, should be waterproof and strong, approved material. Locking bars and side wedges should be in place and in good order. Inspect all machinery space openings on exposed decks. Check the manhole covers on the freeboard deck are capable of being made watertight. Check that all ventilator openings are provided with efficient, weathertight closing appliances. All air pipes must be provided with permanently attached means of closing. Inspect cargo ports below the freeboard deck and ensure that they are watertight. Ensure that all non-return valves on board overboard discharges are effective. Side scuttles or the portholes below the freeboard deck or to spaces within enclosed superstructure must have efficient internal watertight deadlights. Inspect the rubber seals and securing arrangements. Check your freeing ports, which are below your bulwarks. Ensure shutters are not jammed, hinges are free, pins are non-corroding type. Check the bulwarks, guardrails are in good condition. Rig lifelines and ensure that they are in good order. Derust and repaint deck line, load line mark, load line and draft marks. So on the day of survey, ensure that the international load line certificate associated documentations are available. Sufficient manpower should be available for operation of hatch covers and rigging of staging and ladders to allow the surveyor to view the load line marks and draft marks. And your stability data book should be available for inspection. So that is for your load line, and now we'll do certain more things. This is a regulation A, with the tables of freeboard are there. So this is a shear, the 3D view for you. Now, what is a load line exemption certificate? So when the ships are on international voyages between near neighboring ports, they may be exempted by the flag state on provisions so that they remain engaged in such voyages. And the governments of these states in which these ports are situated shall be satisfied that the sheltered nature or condition of such voyages are make it unreasonable or impracticable to apply for load line convention, then you can have load line exemptions. Second is any ship shall, however, comply with the safety requirements with the opinion of administration are adequate for the service in which it is intended and are as such to ensure that overall safety of ship and that is acceptable to the government of state to be visited, then again you will be exempted. Administration which allows any exemption shall be communicated to the IMO. The particulars of same should be the reasons, and then the IMO will circulate to the contracting governments about exemption. A ship which is not normally engaged on international voyages but is in exceptional circumstance required to undertake a single international voyage may be exempted by the flag state on any load line requirements, provided it complies with the safety requirements in which, in the opinion of flag state, is adequate for the voyage which has been undertaken by the ship. When exemptions to the ships are allowed, the vessel shall be provided a load line exemption certificate, and the bottom line is such that the ships of over 24 meters in length to which load line convention applies need to have either load line or load line exemption certificate. So this is your load line exemption certificate that's issued under authority, particulars of ship, name, distinctive letters, port of registry, length, IMO number. This to certify that the vessel has been exempted from the provision convention under the authority conferred by the article of this convention. Now for the shear, your formula is this one, shear credit. So when the shear profile differs from standard, the four ordinates of each profile and the forward and half shall be multiplied by the factors of Simpson's rule 1331. Difference between the sum of the respective products and those the standard divided by it measures the deficiency or excess of shear in forward or aft. Arithmetical mean of the excess or deficiency in the forward and aft halves measures the excess or deficiency of shear. So the shear credit will be given by this formula, which is S is equal to Y by 3 into L dash by L. Well, S is your shear credit to be deducted from the deficiency or added to the excess of shear. Y is the difference between actual and standard height of superstructure at the end ordinates. That's Y. L dash means enclosed length of poop or forecastle up to maximum of 0.5 L. And L is length of vessel. So that becomes your shear credit as per this diagram. Those notes will be there for you. There you multiply and again find the mean. And what are your side scuttles? So this is defined as round or oval openings of area less than equal to 0.16 meters square. Diameter is less than 0.45 meters. Side scuttles are fitted with the hinged deadlights and the covers on top. For spaces below freeboard deck, spaces within the first tier enclosed superstructure. First tier deck houses on the freeboard deck projecting openings leading below or considered buoyant in stability calculations. Deadlights will be watertight if fitted below freeboard deck and weathertight if it is above. Side saddle shall not be fitted in a position that the sills are below the line drawn parallel to the freeboard deck at the side. The lowest point, 2.5% of the breadth or 500 mm, whichever is the greatest distance above summer load line. That's your side scuttle. So your passenger